All right, howdy guys. This is our final project presentation for Mxet 300. This is Team Place Projectile Launching Autonomous Cleaning Entity.
I'm Jacob Brown.
I'm Britton Corbitt.
I'm Austin Probasco.
And I'm Christian Ramos.
Our mission for this project was to create a scuttle robot that was able to shoot ping pong balls as projectiles. After the projectiles were fired off, the robot would then detect the ping pong balls to determine their location for retrieval. The demonstration started by allowing the user to control the robot to move around and fire the projectiles, which were the ping pong balls, until the hopper was empty. This part of the demonstration was completed when the robot had fired all of its projectiles or through human input with the gamepad controller. After it was determined that all the projectiles had been fired or the user initiated the command, the automated section of the demonstration started. The robot used the camera to determine the location of the ball and then retrieved them. The demonstration ended by either two circumstances: a failure mode, which would be the case after driving around searching for a specified amount of time and not being able to find a ball with no success, and then the robot will enter the failure mode, or by human input after the robot had successfully collected all of the balls.
A camera was used to detect the ping pong balls, determine the location, drive to the ball, and then activate the vacuum to pick them up. This was all done within the autonomous mode for the robot. We ran into an issue of the camera not being able to detect ping pong balls successfully all the time at a long distance. So we created a failsafe that allowed control to be returned to the user so that the robot could be driven closer to the ball and then returned into its autonomous mode to finish out the mission.
The robot had 4 different actuating assemblies. The first one was a motor control that was used to control the wheels of the scuttle. The second one were 2 3.3 volt DC motors that were mounted onto the scuttle using a 3D printed mount. And this was for the ball launcher. The third one was a 12 volt DC motor that ran the motor to control the vacuum. And this controlled a custom printed impeller with an impeller housing that was mounted to a Tupperware box underneath the robot to act as a suction chamber. And then there was a cardboard tube coming out of the front of the box so that it could reach the balls. And then the fourth actuating assembly was a servo motor that was mounted to the PVC on top of the scuttle that would move out of the way to allow the next ball into the DC motors to shoot.
For data collection, the robot kept a running tally of how many ping pong balls were loaded in the system at any given time. This was achieved by incrementing a counter after each successful retrieval of a ball. When the counter hit 0, the robot began searching for the ping pong balls. Once the counter displayed a full capacity, control was given back to the user. And as you can see down below in the little figure, you can see in node red that we have the ammo inside the circle. Whenever it was shot, it would just decrease and become white once it ran out of everything. The battery level, we had that just in case to show that we needed to charge the battery pack and determine how much battery is being used during the operation of the entire thing. And then we have the status control where we have the states where it's either going to be manual mode or autonomous mode. For the mission status, the robot had 2 routines. In the first state, the user was able to drive the robot using the gamepad and shoot projectiles. The robot remained in this state until it ran out of projectiles or until the user pushed a button on the controller to enter the next state. In the second state, the robot autonomously retrieved the projectiles. Once the robot had retrieved all of them, the mission was complete.
There were 2 failure modes built into the software of the Scuttle project. The first one happened when the Scuttle could not find any balls remaining in the room, and it knew that there were balls left to detect. It would go into a shutdown mode then. The second of the failure modes was if the Scuttle got stuck or didn't move for 30 seconds, it would go into a panic mode and then call the user to move it, or it would allow them to move it using the controller.
Here's the demo video for the project.
In In this demo, the servo was able to clear the way for each ping pong ball, and the motors remained in place for adequate firing speed. Fortunately, the camera detected all ping pong balls without user interference. There was a slight pause between the firing and retrieval process, but besides that, it functioned as expected.